Hi, it's Reda here. In the previous video, we've spoken about complex numbers, just in terms of theory to understand it and to give it a good definition. But for today, we're going to go through a couple of examples just to make it simple and easy to understand more how to use it to solve a couple of mathematical problems. All right, let's start with this. I've got in here on the board, all right, simple exercise, but if some of you might find it slightly tricky or it could be easy, which I hope so. All right, we've got two questions, which first questions is just one question. Second part of this exercise, it's made up of two questions, A and B. But in here, I'm gonna start first with the first question. First question says, write real part of this number 5. Real part. Just to a little reminder about what we spoke about in previous video, we said we basically give it a symbol as a Z for any complex number. Any complex number, we can write it in terms of A plus B I. A and B, and B belongs to R, which is reals. Basically, A and B are real numbers. If we write this number, let's say here Z equal 5. What that means, basically equal, if you want to write it in this way here, because every single complex number has to be in this form here, basically 5, what that means, we've got A equals 5, there is no I in here, basically it's I times 0 equals, plus 0 times I. Then the real part of this equation here, or this formula here, is 5. This is the real part of it. And the imaginary part, as we said, every single complex number got real part and imaginary part. Real part in here is A, imaginary part is B. In our example, real part is 5, imaginary part is 0. This is imaginary part. In our example, we ask us to find a real part. Basically, real part is 5, as simple as this. You can write your answer. Simply saying, real part of this formula here, which is 5, but we have to leave it in there. We can't just write 5, because 5 like this is just a number. We don't know if it's a complex number, it's a real number, not a real number, we don't know. You have to say, basically, Z equal A plus B I. A and B belongs to R, which is real numbers. I have to give it a definition here, and then Z equals 5 plus 0 times I, which is 5 is a number of this complex number, which is 5. Second example, 17. Let's say Z2, if we say this is Z1, just to, otherwise going to be a confusion here, Z and Z, that means this equals this, you have to give it a definition and separation. Z1, Z2 here, Z2 equals 17I. How can we write this formula here in terms of A plus B times I? Is that simple? This in here is 0 plus 17, equal 0 plus 17I. A, B, as simple as this. Then, the real part of this Z2 is 0. This is the real part. The imaginary part is 17, and we call it, this is the imaginary part because it's 17 times I. Real number times I is imaginary, we call the imaginary part of our complex number. And the first number, which is not related to I, we call it a real number. But this one here, I and B, this is just to, that simple exercise is just to remind you about complex numbers. If we go to part 2 here, part 2 is slightly interesting, but the more exercise you do, the better. You have always to practice to make things easy and understandable, and you go straight forward in your exam to solve any problem. But here's just a couple of examples. We've got here two complex numbers, Z1 and then Z2. You've got the formula, which is that simple in here. The first question, which is, you've got two parts here, A and B. A says, giving your answer, it's like writing the answer of delta here in terms of x plus y I. X and y part, x and y belongs to R. What type of example you have to use or to write, which is 2z1 plus z2. Basically here just symbol which is start. If you remember, we said z1 is, or z, it's a complex number. Z, basically power, or just to put a symbol in here which is a star. We call it as simple as this, we call it conjugate, or the opposite number of z1 on the other side, which is, let's say, 1 minus 1, 2 minus 2, and z, here just to remind you, z start, we write it this way here, it's a minus b I. Then, to write this side in here, to write this formula here, t z1 plus z2 start equals, alright, z1 we've got as simple as this, 2 times 3 plus 4i plus, we've got z, what we said, z2 start, which is 1. Here we've got minus 2i, it's going to be plus 2i. Why? Because z starts, we call a minus bi. Basically, it's 1 minus 2i. We become now 1 plus 2i. That's it, as simple as this, 1 plus 2i. And we distribute now, it's going to be 6 plus 8i plus 1 plus 2i plus 1 plus 2i. As simple as this. Now it's like that easy piece of cake. We call it now we go to the next step. Then we have a way we added complex number to complex number. It has to be real with real and imaginary number with imaginary number. Basically 6 plus 1 equals 7 plus 8 plus 2 is 10. And our problem is solved. Basically we find the answer of our question we asked to do, which is, it says you have to prove it, so the answer has to be this way: x plus yi, x plus yi, 7 plus 10i. Okay, now the second example here, which is, this is the first one, second one, which is z1 divides by or divisible by z2. What we have to write now is just replace these two, z1, z2, by the same thing like being given to you in your exercise. It's going to be 3 plus, as simple as this, always go back to your exercise. It's like what we've been asked to do. Divide by 1 minus 2. Oh. Then what we have to do, in order to use this part in here, what you have to do, you have to write it basically in here, you have to write it in the conjugate side of z2. And then, because you need to get rid of I in here, this I has to come out from the bottom equation here. This I, you have to get rid of it. Doesn't matter on the top, but on the bottom here, we have to get rid of I. To get rid of I, you have to times this, times duplicate by the same number here, but the conjugate, and then to write it in this way in here, because we let's write it in here. A minus b times a plus b equals a square minus b square. When we say this is going to be the real number, and then the imaginary number is going to be b I square. B I square I is minus 1. And then minus 1, and then it's gonna be here b times minus 1, and that means we get rid of I. I'm gonna explain it here now. Sorry, I need just to clear my board, and I'm gonna explain it here. It's that simple and easy. As I said, all you have to do is just a little practice, and then get used to it. Equals in here. Alright, let's start with the bottom side of this equation. We said 1 minus 2i times 1. The conjugate number of this complex number is 1 plus 2i. And then here, if we said 3 and plus 4i, if we divide the top, the bottom with this number here, it's like basically there, it has to be the same on the top as well. And then we can get rid of it if we want to go backwards. Basically 1 plus 2i. This equation here equals this equation, because what we do, we divide the top and the bottom of this equation with the same number, which is 1 plus 2i, 1 plus 2i, as simple as this. But 1 plus 2i is the conjugate number of 1 minus 2i. Okay, in here now, we have to start always with the bottom because this is what concerns us. This is what is really important for us. This is going to be exactly what I wrote before, and then just I took off 1 minus b times 1 plus b equals 1 square minus b, a square minus b square. This is our a in this example here. This is a minus b times a plus b, a square minus b square, a square which is 1 square, minus b square is 2I square. As simple as this. All I did, I just applied this formula here in here. That's all I did. In here now, it's simple as this. We have just to distribute this as simple as this. 3 times 1 is 3. 3 times 2i is 6i. Plus 4i times 1 is 4i. 4i times 2i is 8 minus 8 square, which is I square is minus 1, which is minus 8 in here. Because here 2i times 2i times 4i is 8. 2 times 4 is 8. I times I is minus 1 is minus 8. As simple as this. And then what we're going to do here is just simplify it now. We've got 1 in here. 1 square is 1. 2i square is minus 2 because I square is minus 1 times 2 square is 4. Basically here all of it is become minus 4. Minus 4 is plus 4. And then here we have to simplify it. We've got real number, imaginary number, real number, and then we have to add it, imaginary number. 3 minus 8 is minus 5. 6 plus 4, 6i plus 4i is 10i. So, we have, we're going to do this one here, 5 plus 10i divided by 1 plus 4 is 5. How can we write this formula here? We've got this side in here, let's say a, just to explain, a plus bi divided by, we've got 5 and 5, basically it's same, it's I, equals I divided by I plus B divided by I times A. A divided by A plus B divided by A times I. And then now, we can write the same formula here, and here. Let's just clear the board for you, then you can understand what I'm going to write in here. So, we've got 5 divided by 5 plus 10 divided by 5 times I. 5 by 5 is 1 plus 10 divided by 5 is 2I. Sorry, 2I. And we found the answer of our question. This is the question. Z1 divided by Z2 equals 1 plus 2I, which is the real number is 1, the conjugate imaginary number, sorry, is 2, and this will been asked, we have to write it this way, which is x plus y, 1 plus 2i. And then now we've got the last question, which is B, what they ask us to do, which is solve this equation V square equals I. We have to write it in, we have to write it this way in here, which is x plus y z. We have to write it this way in here. Okay, and then z, what is it? Here, just to explain things, z equals a plus b I. Then z square, I just write it here, equals a plus b I square, equals here a square plus 2 times a b square, this is quite well known, plus the second part square, which is minus b square. What we said minus b square because b I all square, which is b square times I square. I square is minus 1, which is equals minus b square, and all this equals I. So from here, z square equals, here we've got here, and this is a real number, and this is real number, is going to be a square minus b square. This is a real number. And then here we got imaginary number, which is 2ab I minus I, if we move it this side in here, equals 0. So in here, what we can get from here, we've got a square plus b square, a square minus b square in here, plus 2, we got imaginary number a and I, 2ib minus 1 times I equals 0. This is what we can get from here. Basically what we managed to do in here, we create it, basically we write it in terms of a plus b I equals 0. And now it's like much further to find what is it a and what is it b. I need just to clear the board here for you, because remember the question asks we need to find a and b, and we need to see what is it a and what is it b. Cool. Okay, so in here now we've got a minus a square minus b square. A square minus b square equals 0. It's basically, if you got complex number here, just because my there we go. If you got a complex number, which is the first one is a real number plus imaginary number equals 0. That means the real number equals 0 and imaginary number equals 0. This is our equation here. That means a square minus b square equals 0, and in the meantime 2ab minus 1 equals 0. This is what we've got so far. Then from here, what we can get from here, basically b equals, if you move 1 towards other side, divide by 2a. A has to be completely dissect and doesn't equal 0, because if you said 1 divided by 0 is going to be 0 here. And then we've got b. This is what we found about b. We have to put it back in here in terms like first equation is going to be a square minus 1 divided by 2a all square equals a square minus 1 divided by 4a square equals 0, and a doesn't equal 0 here. And then what we can do, we can make it's like the bottom here same, is going to be a 4a square times a square, which is going to be 4a all power 4 minus 1 divided by 4a square equals 0. Basically what we did, I made it in the same here, the same as what we called it, a same bottom in here, which is 4a square. And then from here what we're gonna go for, basically if we got x divided by y equals 0, it's x equals 0 I, or I equals 0. Basically from here we said I doesn't equal 0. Basically we've got back to 4a power 4 minus 1 equal 0. And then from here what we can go for, 4a square equals 1. Basically I moved 1 toward this side in here, and then from here a power 4 equals 1 divided by 4. And then because here it's for a power 4, if we said, let's say q equals a square, what we can write this equation here, I have to clear the board in here. There we go. And then we can explain our exercise. Here we go. Okay, and then from here, what we can go for, then we've got in here q squared equals 1 4. You have to remember this. So from here, we've got here square root of q equals 4 square root of 4, and then from here what we can get is q equals 1 divided by 2. This for q. We've got q equals a square. So a equals 1 divided by square of 2. This is what we've got for a. Or a could be 1 divided by minus, because both of them gonna give me a. Both of them gonna give me a when I said a square. Because if we set a square in here, it's going to be 1 divided by 2, or a square in here is going to be 1 divided by, minus 2 square roots. And then from here, what we can get, basically you have to take it back to this equation here, which is going to be b equals, if we put this equation here back to here, it's basically going to be 1 divided by 2 a which is 1 divided by square 2, and then what we have to do is basically going to be square 2 root square 2 divided by 2, because it has to go on the top of it completely the opposite. This is for b. First b1, if we said this is a1, this is going to be b1. If we said a2, and then that means we have to find b2, which is going to be, it's basically the same, 1 divided by 2 times 1 minus 2 root square, and then it's going to be minus 2 root square divided by basically 2. This is going to be b2, and then we find our a and b. Basically a, which is the symbols of numbers of a, and this is symbols of numbers of b1 and then b2. Then our problem, this problem we had before, we asked to solve it, z power 2 equals I. It basically in here we've got we've got 4 basically. In here we've got 4 solutions, a1, a2, b1, and then b2. This is slightly complicated exercise, and now it could be maybe slightly difficult for you to understand into, but what I would say is, in maths you have always to practice and see, sometimes you could be wrong, you have to go back again and do it again and do it again until you get it correct. And the more you do exercise, the more you do it, the better you get with it. Maths is about practicing and practicing and practicing about exercise. And please be patient, take your time and to solve your problems, and always go back to the foundations. Don't anticipate and don't go fast, focus and go slow with your numbers. In the next video we're gonna carry on talking about the new topic, a new chapter of our complex numbers. And then if you got any questions in the meantime, drop me a text or drop me a comment. I'm more than happy to help, and I will see you in the next video. Speak soon.